In this video, I want to show you how to name cycloalkanes. Cycloalkanes, like normal alkanes for naming, substituted cycloalkanes use the cycloalkane for the base name with the alkyl group name as substituents. And if there is only one substituent, we have no numbering. So no numbering is needed when there is only one substituent. So as you see in the left hand side, we have methyl cyclopentane. In the ring, we have 5 carbon atoms, so that's why we have cyclopentane, and we have one substituent which is methyl group. So that's why we have methyl cyclopentane. The middle one is we have the ring, and how many we have there? 1, 2, 3, 4, 5, 6, 7 carbon atoms. So we are dealing with a cycloheptane. And we have the alkyl group, which is called tertiary-butyl. Tertiary-butyl cycloheptane. So because we have only one substituent, we just name it. We don't need to number it. So we have tertiary-butyl cycloheptane. On the right hand side, again, we have only one, but it is complex one substituent. So how many carbon atoms we have on the ring? We have 1, 2, 3, 4, 5, 6. So that's why we are dealing with a cyclohexane. And what is the substituent? Substituent is called, the complex one, it is called 1 and 2 dimethyl propyl cyclohexane. So that's how we need to name it. If there are 2 or more substituents on the ring carbons are numbered to give the lowest possible numbers for the substituted carbons. The numbering begins with one of the substituted ring carbons and continues in the direction that gives the lowest possible numbers to the other substituents. In the name, the substituents are listed in alphabetical order, when the numbering could begin with either of 2 alkyl groups. Begin with the one that is alphabetically first. So let's take a look to this example. So on the left hand side, we have 4 carbon atoms on the ring. So which one we need to start with? So we need to start with the bottom one. Why? Because we said the numbering begins with the one of the substituted ring carbons and continues in the direction that gives the lowest possible numbers to the other substituents. In the name of the substituents are listed in alphabetical order. So we have 1, 2, 3, 4, and we have 1 ethyl, 2 methyl, cyclobutane. And here we have 5 carbon atoms on the ring. We have 2 methyl here, and we have 1 methyl here. So that's why we need to start with this one. So, and we need to go this way, not that way, because if we go that way, this will be number 1, 2, 3, 4. But if we go this way, it will be number 3. So we have 1 and 1 and 3 trimethyl cyclopentane. And then on the right hand side, we have 6 carbon atoms. And which one we need to use? We need to start with this one for numbering. So it doesn't matter if we go this way or that way. So we have 1, 2, 3, 4, 5, 6. And we have 1 and 1 diethyl 4 isopropyl cyclohexane. When the cyclic portion of the molecule contains more carbon atoms than the cyclic portion, or when it contains an important functional group, the cyclic portion is sometimes named as a cycloalkyl substituent. For example, on the left hand side, as you see here, we have this long chain. So 1, 2, 3 all the way to 8. So we have 1 methyl group here, and we have a cyclopropyl here. We call it cyclopropyl because it lost 1 hydrogen atoms. So we call it 4 cyclopropyl 3 methyl octane. So we started with the cyclopropyl because you need to do it in alphabetical order. And here we have the same thing. So we have the triple bond here. So 1, 2, 3, 4, 5. So we have 5 cyclobutyl because we have 4 carbon atoms. 1 pentyne. And here we have cyclopentyl cyclohexane. Why? Because this one is bigger than the other one, so this one acts as a substituent.